This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club seminar series. This is session number 66. The title of today's presentation, Utilizing NUCAPS for Supplemental Observations in a Convective Environment. Our presenter, Kaitlin, a meteorologist at the National Weather Service Forecast Office in Amarillo, Texas. Our facilitator, Jarrell Torres, Research Associate and JPSS Satellite Liaison at Sierra, Colorado State. Hope everybody's staying well. Just a few reminders before we get started that the session is being recorded. We will have an opportunity for Q&A after the presentation, so please post your questions in the chat and we will use that to direct them to the presenter. We are always looking for future presenters, particularly from our field offices. So if you have an application you'd like to share with your colleagues, please get in touch with us. The training team can help create training materials that may be unavailable. Brian Mata, Office of the Chief Learning Officer, can assist you with information or questions regarding that. Thanks to the Tower S team, particularly Kashad Bowman and Lee Byerly, the Office of the Chief Learning Officer, and GOZAR and JPSS programs for their support of the Satellite Book Club. And thanks to all of you for being with us today. Another great number of attendees, over 60 participants. Without further ado, I'd like to introduce Kaitlin, a repeat presenter here at the Satellite Book Club. She is a third-year forecaster at the NWS in Amarillo, currently the satellite focal point for the office and tries to bring the use of satellite products to everyday operations. She's also a member of the NUCAPS working group and has provided valuable feedback on the usefulness of the products operationally. Kaitlin, welcome back to the SBC.
Thank you, Jordan. Okay, so today I'm going to talk about utilizing NUCAPS for supplemental observations in a convective environment. So there's 2 days in particular I'm going to focus on. They're both from this year in May 3rd and then May 16th. So we'll start with May 3rd of 2021. So this is just a synoptic overview. You can see in the 500 millibar analysis, there's a trough present over the Four Corners region, and that's going to provide additional lift and descent across West Texas. And then you can see in the 850 millibar analysis, there's a closed low over Northwest Texas, and that actually brought a cold front, surface cold front through West Texas before stalling out between Lubbock and Midland, Texas area. And the front actually brought decent low-level moisture with low 50s dew points along and right behind the front. So SBC did issue a meso discussion at 19Z, and that did show an area of agitated cumulus and a narrow corridor of instability, and that was going to be right along where that front had stalled out. So looking at some of the SBC mesoanalysis page, it showed at 20Z a corridor of 500 to 1,000 joules per kilogram of ML CAPE, and that was again right along that frontal boundary with no capping inversion, as the temperatures did warm into the mid to upper 70s along that stalled cold front. And just north of that front, the temperatures were in the mid 60s, while further south, near kind of Midlands area and south of the front, they did get into the lower 80s, so they warmed up pretty nicely. As you can see, ML CAPE does increase further east you go into central and eastern Texas, but they did have that SIN as of that time, but they did end up breaking that. So on the right-hand side, you can see the 0 to 6 kilometer shear is nearly 50 to 60 knots along the same narrow corridor, and that was just south of Lubbock, Texas. And so basically, we're looking at isentropic ascent along the surface boundary. That's going to lead to the potential of storms just north of where the boundary was to stall. So if we look at our mid-level lapse rates, you can see that they're pretty modest. You get good shear setup and environment capable of strong updrafts and large hail. On the right-hand side, I've chosen to plot out some of the gridded NUCAPS just to give an idea of what the satellite was showing of the environment. And you can see that gridded NUCAPS actually kind of showed a little bit of a better corridor of those higher mid-level lapse rates. So on the left-hand side, you'll see that black box. That's basically to show you what's the area that's shown on the right with all the NUCAPS data. So you can see that it's kind of in the same values area range, 7.5 degrees per Celsius. It looks like the wrap is showing around 7.5. So values are not very far off, but one thing that the NUCAPS did provide is a little bit more detail, again, with that corridor where that storm is and out ahead of it. So give an idea of maybe there would be a potential of training storms in that area. Moving on to the precipitable water, one thing to note is that on your SBC mesoanalysis page, that's going to be in inches. NUCAPS does put it in millimeters, so I'll explain in a little, but basically you can see that there's an area of decent P-watts where storms were likely to fire, and then they obviously got better as you moved east. So with the stall boundary, there was also a potential for that training storms, flood potential, heavy rainfall, and concerns. So looking at the gridded NUCAPS, you can see that that storm that did start to form initially early on around 20Z was forming in a corridor of, and that's around 2 inches, 2+ inches of total precipitable water, which is actually higher than what SBC P-watts were showing. So definitely you can see that the NUCAPS was showing a little bit higher P-watts and the chance for that potential for flooding and heavy rainfall. So at around 20Z, there was a NUCAPS No20 satellite pass with a chance to see a profile of the environment where storms are forming and moving into, and that we could use that then in comparison with some of the model data. And so in this case, I'm going to look at 3 different soundings and I'm going to compare them to the wrap. So you can see that storms already did start to fire around 20Z, and that's when we got our NOAA 20 satellite pass. So this first sounding's the furthest north, and you can see I circled it on the map, and you're going to see that it did have a pretty, let's look at it compared to the wrap, but the wrap did have in the same location a pretty potent inversion, where the NUCAPS sounding shows a little bit of a smaller inversion, and thus it was picking up a bit more CAPE due to that. But this is easily can be due to the fact that the NUCAPS profile, if you take a look at the surface temperature, is actually a bit lower than what the wrap had. And so the NUCAPS profiles tend to, you have to think that they tend to struggle with the surface temperatures more than a model will because it's scanning from higher up. So it's up in the sky and it has to make it all the way to the surface. So that's something to take into consideration. But if you were to take that NUCAPS sounding and realistically look, you could basically think about if the temperature was warmer, it would show a similar profile and maybe even would break that cap. So as you can see, the CAPE values in the wrap sounding are around 196 with ML-SIN of -218, where the NUCAPS was showing almost ML CAPE values around 500. So again, could be unrealistic as it's not picking up, as strong of that inversion. As you can see, we knew the stalled cold front was south of this area. So there is a potential that we were going to have more SIN on this one. If we move on to the middle sounding, so this one's more right ahead of where the storm was going. And again, it's still a little bit further north than the front. But you can see with this sounding that there's a little bit less of an inversion. You can tell that just because there's slightly more CAPE in the wrap sounding and less SIN. However, if you look at the NUCAPS sounding, again, there's not as much of an inversion, but we are looking at temperatures that are slightly lower too. So the NUCAPS profile, if it realistically had the proper surface temperatures, may not even have an inversion like the wrap did. And it was already showing lower CAPE values. You can see that the ML CAPE values for the NUCAPS profile was 150 with about 175 SIN. So you can see that, even if we had warmed the temperatures and modified the NUCAPS sounding just a little bit warmer, we would probably get closer values of CAPE in comparison to the wrap. And then the last sounding basically was in and near the front. So it's right around that frontal passage, and the wrap you'll see has the smallest inversion on this one. And you can see that it had the most CAPE. So we're getting anywhere from around 1200 ml CAPE with the wrap. And the SIN is pretty much non-existent. It's around 21, so it's pretty small. But if you look at the NUCAPS, what's interesting is the CAPE values are actually lower on this one. So again, it's not doing well at picking up that the environment's pretty unstable here. And again, that's a lot of that has to do with the surface temperature. Had it been warmer, it looks like surface temperature is around 28 on the wrap, and it's about 10 degrees cooler on the NUCAPS. So if you were to warm that temperature and modify that sounding, you would likely get higher CAPE value. The NUCAPS sounding is showing 184 with a decent inversion with 223 SIN. So that was one thing that the NUCAPS did struggle with, was the fact that the surface temperatures were a little bit unrealistic and a bit lower than the wrap was showing. And so you can see that the CAPE values weren't super realistic as well compared to the model analysis. But one thing that I do want to note with the NUCAPS that you can see basically with all of these soundings is that it does do a pretty good job with looking at lapse rates. So they were pretty comparable to the wrap sounding. So there were no observed soundings done in the same time where the storms were initiating. Lubbock does not do upper air soundings. The closest would be Midland and Amarillo. So sometimes the NUCAPS can be that best observational look at the atmosphere. However, you have to take into consideration some of those things like the surface temperatures and always compare it to the models and see how the models are doing. So with this slide, you can see on the left-hand side is your GOES East visible satellite, and you'll start to see some of those. Well, first you see the front coming down, and you can see that storms later fire along that front through the evening as it pushed further south. Once again, the environment immediately behind the front did contain good low-level moisture and was supportive of supercells. You can also see that there's a pretty low stratus deck that did follow in behind the front during the morning hours, but that did remain further north, and it did cause limited heating across the Texas and Oklahoma panhandles, which really kind of put an end to any kind of storm potential up there. Then the infrared channel on the right does a good job at looking at these storms and see that they were not cooling as much as the storms in eastern Texas. So they did have pretty decent storms in eastern Texas where the instability did increase over there. But you did see we do get a few storms along that front. But one thing that you can see in both of these products is the amount of shear that was present. We said there was about 50 to 60 knots of shear, and you can actually see that with that quick northeast spread of those anvils as the storms do form. So you can tell that that shear is present. But also, if you look closely enough, sometimes you can even see some of those rotating updrafts inside of those storms. So then if you look at the day cloud phase distinction band on the RGB on the left, it does a wonderful job at showing that low stratus deck in the north. And so those are your more water type clouds, blue, and that's across the Texas panhandle. And then it also does show some cumulus clouds along the front that do eventually become agitated as they begin to grow and glaciate and they do turn into more of that greener color. And then once they start maturing into a strong to severe storm, you start to get those yellow, bright orange colors. And then on the right-hand side is your GOES 16 or GOES East clean IR and window. And then it's also got your total precipitable water from GOES 16. And that does show that the storms are forming in an area of 1+ inch PWatts that increase with time and as you go further east. And so the GOES 16 PWatts are slightly higher than those from the SBC mesoanalysis page, but that could be due to the fact that SBC's PWatts represent the lowest 400 millibars versus the entire profile like the GOES. And so overall, the day did lead to multiple hail and wind reports with a few large hail reports of around 2.5 to 2.75 inches. And there was a high wind report around 84 miles per hour as the storms did move further east into north central Texas. So you can see the storm reports lining up basically where that front had stalled out. And you can see with the radar imagery We did get some severe storms that did begin to form along that frontal boundary, and they did sort of train through the evening hours and overnight. So you can definitely get that hint that there was going to be a potential for some flooding issues and things like that, as there was multiple storms that continued over the same areas. And so next I'm going to move on to May 16th of 2021. So just going back to the synoptic overview, there was an upper low across the California and Nevada with a weak disturbance aloft that had ejected ahead of the low across West Texas. And then meanwhile, you had in the 850 millibar, you can see that there's a surface trough present on the lee side of the Rockies and extending south into eastern New Mexico. In addition to that, there was also a dry line present across West Texas. And you can kind of see that with your dew points. So they did SBC did issue a meso discussion at 22Z, and that kind of just highlighted the dry line position and also a stationary boundary for an area where strong to severe storms were likely to initiate and persist through the afternoon hours. So at around 20Z, there was a NUCAPS NOAA 20 satellite pass with the chance to see another viewpoint of the environmental instability in comparison with the models. And one thing I wanted to show was this is the quality flags for this time. And you can see that there's actually a red pixel in northeast New Mexico, and that just indicates bad quality. Basically, it's missing both the microwave and the infrared components. So in this case, when I go through the gridded NUCAPS, you can basically ignore that pixel. It will kind of look erroneous, and so you know that it's of bad data quality, and this is where you can check that out at. Otherwise, all of West Texas has good quality data of both components. As you can see, it's green. So first of all, comparing the mid-level lapse rates at 20Z between the mesoanalysis and the NUCAPS, you can actually see they're pretty comparable, around 8 degrees per Celsius lapse rates across Texas and New Mexico border. And then both show decreasing as you go farther east. And then if you move on to the precipitable water, it does show values increasing the further east you go. And the NUCAPS does do a good job at showing that gradient, similar to what SBC mesoanalysis page was showing. And the values, again, are pretty comparable once you change the millimeters to inches. They actually were very, very similar in their readings. So at 21Z, the SBC mesoanalysis page was showing a pocket of higher CAPE near and just southwest of Lubbock with around 1,500 to 2,500 joules per kilogram. But one thing I wanted to quickly show was the 0 to 6 kilometer bulk shear. It's pretty small. I mean, there's really not much going on in the Texas Panhandle, but as you move further south towards Lubbock's area, you maybe get around 25 knots of shear. But again, not super impressive enough to sustain a strong to severe storm, but not looking at anything major tornadic at this point. If we compare the 21Z goes east visible with the goes east CAPE, you can actually see that the goes east did pick up on that tongue of higher CAPE values. Even though they're slightly lower, they're about 1,000 to 2,000 joules per kilogram compared to the RAP. But that tongue of higher CAPE, unfortunately, was a little slightly further east in the satellite compared to what the mesoanalysis was showing. However, you can see the dry line position pretty well with this GOES CAPE. You can see where the values right along that edge, it kind of goes down across Sudan, Texas, which is northwest of Lubbock. And so it was kind of cool to use. It's cool to utilize this product to even see some sort of surface features as well. So this slide does show the Sudan storm, which I'm going to spoil now. It did become tornadic, and that will help me explain some things later on. But that left image was basically right at the time when that storm did become tornadic. And then you can see on the right-hand side, just west of the greatest area of instability, you can see the progression of the Sudan storm along that dry line. and how the instability decreased overnight as you go into the evening hours as daytime heating was being lost. So you can see that those CAPE values were decreasing with time. So here's the 19Z NUCAPS sounding that we were able to get, and I am comparing it to the 22Z wrap sounding just due to the data that I had available to me. And so one thing at first glance, you can see that the soundings look similar. They have very similar lapse rates and moisture present through the profile. However, there are a few glaring differences here. The surface temperature value, again, is lower in the NUCAPS, which is tending to lead to a smaller area of CAPE. However, we do have to note that this NUCAPS sounding is 3 hours earlier than this wrap sounding too. So temperatures were likely expected to warm a bit through the afternoon hours and become more like the wrap sounding. So you can kind of get that inferring. Also, another thing to note is the EL is a bit lower in the NUCAPS profile than it was in the wrap, but again, a few hours earlier, luck change in that. And with the NUCAPS sounding, you do miss out on the wind profile, which is something that's kind of unfortunate when it comes to the satellite. But basically with the wrap sounding, you can infer the location of the dry line. So in this point in time, you can see that that the wrap sounding shows this location was right just west of the dry line or right along it. So looking deeper into the exact values that the soundings were showing, the ML CAPE values were actually pretty comparable between the two profiles. As you can see, the NUCAPS sounding was showing ML CAPE around 2400 and the wrap sounding was showing ML CAPE around 2500. So pretty comparable between the two. Both had a little bit of SIN present, but not much. Also, another thing that you can see between the two soundings that was comparable were the PWatt values. They were both around 0.85, 0.88 inches. So, I mean, pretty comparable. Again, with the whole moisture profile, they were pretty similar. And then there's some other variables that were also similar that you can take a look at here. But one thing I want to point out is the lapse rates. They're similar, but one thing to note is that the NUCAPS sounding does show a bit of steeper lapse rates than the wrap does. Not much steeper, but it's steep enough. And so then if we take a look at the goes east day cloud phase distinction and then the visible IR sandwich, these products are both great in terms of mesoanalysis and overall storm interrogation. So you can get a good big picture sense. So if you're the mesoanalysis that day, both products are showing the storms firing in eastern New Mexico along what we said was that surface trough, and then they're moving east towards the dry line. So additional storms can be seen also forming along the dry line later in the evening hours in the southern Texas panhandle, just on the northern periphery of these images and GIFs. So the day cloud phase distinction band is really great for seeing these low-level cumulus clouds that are more of the shallow convection versus the deeper convection. So you kind of get that sense of the difference between where's your shallow convection versus your deeper convection, which you may not get to see as much with just a visible band. So here's your goes east visible and vis-IR sandwich. And I do want to note there was a meso over the location. So these are 1 minute scans, which actually are really great for use during severe ops because you get a quicker updates to the satellite and can see those smaller scale features within it. So just comparing the visible to the sandwich product, it just shows that the sandwich product, so the one on the right, can sometimes provide additional detail that you may not see with just the visible channel otherwise. So the visible channel, it does show the overshooting, so you can see those bubbling cloud tops, but it doesn't necessarily show the intensity or cooling aspect, which are the stronger updrafts. Where the vis-IR sandwich product does a great job at showing the different updrafts present, as there were a few storms actually in a cluster around that Sudan area that afternoon, and you can see the strongest overshooting tops. So you can see that there's colder brightness temperatures for those stronger updrafts. And so this is where you can see right Sudan, which actually was at Sudan due to the parallax issue. But you can see that strongest updraft that was basically that supercell that we're focusing on. In both, you can also see the instability to the east of the low level, to the east with low level feeder clouds that are moving north into the storms through the afternoon hours. This static, however, give a better look at the above anvil cirrus plume and even to a rotating mesocyclone that became present through time, and it later became a tornadic supercell. So using satellite in this scenario could have helped in seeing a high base storm was headed towards a surface boundary, in this case a dry line, and could potentially increase in intensity and maybe even pick up some stronger rotation as it intersects with an area of convergence. So this is where satellite could be really helpful for getting that bigger picture look at things. This is just a still image that shows the vast difference between adding just the infrared channel to the visible so that you can see features that are not as distinct or clear in the visible channel. So I just wanted to take a look real quick at the radar just to kind of show it. So this is Lubbock's radar at the half-degree tilt of the Sudan supercell. And you can see this is about 32 feet above ground level. And you can see that there's not a strong signature screaming tornado on the velocity. Basically, you're seeing decent outbounds, but the inbounds were not being picked up as well on velocity. And part of that could potentially be due to the storm being a low precipitation storm and not much hydrometeors to scan at that time. So I wanted to show a comparison. So now this is the Lubbock's radar on the left at the 1.5 degree tilt, and that's about 7,200 feet above ground level. And then if you look at the right, that's Amarillo's half-degree tilt at around 7,800 feet above ground level. And you see the vast difference between the two. Lubbock's radar was picking up a bit more stronger outbounds just because we're a little higher, you know, in that meso area. But it still was struggling with those inbounds. And again, that could be potentially due to the angle of scanning coupled with the storm's properties. However, the Amarillo radar does show a very strong meso present. And given the environment and the fact that the storm was intersecting with a boundary that had strong convergence, the Amarillo radar displayed a clear image of the storm's progression and the potential for a tornadic supercell. So this just goes to show basically that radars can sometimes help in the warning decision-making process, and looking at surrounding neighboring radars may even give a better idea of that. So overall, there was one single tornado report in West Texas, and that was the Sudan, Texas supercell. But there were a few large hail reports that up to 2 inches, as you can see with the radar. Amarillo's area did have a decent amount of supercells that occurred across their area, but you just had that one isolated down near Sudan that happened to latch onto that dry line and start to rotate. And so I put, this is just a quick time lapse in the bottom right of the supercell at Sudan. So you can see it's pretty low precipitation, and it does spin up very fast. It was a very quick and short-lived tornado. So I'll just let it play here for a second. Oh, okay, well, I guess it didn't show it. Oh, yeah, it did. Sorry, it's very quick. There it goes. So touchdown, and then it picks right back up. So pretty short-lived, not a ton of shear present during that day. So it was really kind of just the boundary that helped drive that. And with that, I'll take any questions.
All right, thank you, Kaitlin, for that great presentation. This is Jarrell Torres, and I'll be facilitating the Q&A session here. But before we do, I wanted to encourage our attendees to stay on for discussion and to complete the feedback survey that is posted in the chat. I believe Lee just posted that as of right now. And please feel free to share any feedback you have, whether that be on the session or the SBC. Also, I wanted to mention in a week from today, on Thursday, September 16th at 12 p.m. Eastern, Bill Line, a physical scientist from the Regional and Mesoscale Meteorology branch of NESDIS STAR, will discuss satellite imagery applications during burn scar flash flood events. So we'll look forward to that. Also, I would like to encourage our attendees to contact the Tower S team, that is Lee Byerly and Kashad Bowman, for questions about the SBC or for configuration of satellite products. And as we lead into the discussion here, I also wanted to remind our attendees to submit questions or indicate that they want to ask a question verbally within the chat. So Kaitlin, I'm going to go through the chat here and start with the questions from our attendees. And the first one here is from Scott Lindstrom from Sims, and he was referring to your slide 8, or the slide 8 sounding, or he mentions that the slide 8 sounding looks vaguely EML-ish or elevated mixed layer-ish in the upper troposphere above 500 millibar. His question is, did band 8 or band 10 show a signal for an EML in them?
Okay, yeah, let me just going back to slide 8 to pull that up. Yeah, so I actually did not take a look at band 8 or band 10. So that's something I definitely will go back and take a look at, Scott, because that is something to note of. So I will definitely go back and look and get back to you on that one.
All right, sounds good. The next question comes from Dan Lindsay. He mentions, is the SBC's mesoanalysis generally considered the gold standard for thermodynamic and shear parameters?
I wouldn't say it's the gold standard, no. I kind of just was using this, I guess, as a comparison. But yeah, obviously the SBC's mesoanalysis page sometimes does have its own issues in a sense where it picks up on some sort of environment that isn't realistic. So you do have to be careful when you're looking at something like that. But I was just kind of trying to compare to a higher res model, just to see if these NUCAPS profiles, which are somewhat supposed to be observational, were kind of close to a short-term model. So in this case, it could utilize the HER if it's doing better, etc. This is just one of the things to compare for the presentation that I did. Okay,
and also I have a question for you. Within your analysis, have you also utilized the advected layered precipitable water product, or ALPW, in complement to your NUCAPS and or GHOST datasets, primarily to observe your moisture component? So say observing your elevated mixed layer or high concentrations of low level moisture.
Yeah, no, I did not. I have not used that actually. That's probably something I need to get into more of a habit of looking at as well, and adding that to some of my procedures. So yeah, I'll definitely, next time we get a chance, or if I'm able to get the data sets, I can definitely look into something like that.
Okay, sounds good. Yeah, I'll have to reconnect with you after the seminar to provide more info on that product, because it's also available via LDM and AWIPS.
Okay, yeah, I do believe we do have that coming in our LDM, so.
Okay, well, that's good. That's good. Okay, now I'll transition back to the chat here. Bill Schoberg asks, did you adjust the surface temps on the NUCAP soundings to determine the impact on the Cape?
I did not do that this time. I am actually utilizing some archive data, so I did have some struggles with trying to get some of this NUCAPS data, as we didn't archive these cases. So some of these images I pulled real time, real quick, during the event, and some of this I was able to pull and try to load up on the WES. So there is some issues there with trying to do some of that capability, but no, I did not get to adjust that. I would like to start trying to use some of the SharpEye modified NUCAPS. It would be cool to see, you know, how they compare to these NUCAPS profiles, since it does modify and try to take into account those surface temperatures. But that was not something I did look into.
Okay. And now Tim Schmidt mentions, nice talk on using the satellite profiles and other products in the pre-convective environment. His question is, in an ideal world, how often would you like NUCAPS-like profiles over CONUS?
I prefer the NUCAPS profiles. I do like them. I don't know if I would say over CONUS. I just like as much as we don't like that fire hose of stuff, it is nice to have different options.
Okay.
And I find that the NUCAPS profiles are nice, especially in a pre-convective environment. Obviously, they're not going to do as well if storms are already ongoing. But here in West Texas, I mean, we have a perfect timing for these profiles coming around 1920 Z, and that's usually right ahead of our convective initiation time period.
Okay. And just in addition to that question, just for myself, in addition to yourself, do other forecasters at your WFO also utilize NUCAPS as well?
I try. I can't speak, confidently that they all are utilizing it, but I do provide guidance on these products and information and procedures, things like that. So there is the capability for them to load it up and utilize it. Now, I'm not sure everyone is, but we do have a fair amount of people, I think, that utilize satellite. Maybe not as much the NUCAPS as since it's still kind of on the newer side for some of us.
Okay, fair enough. And Bill Line has a question. He mentions, what added value do you think NUCAPS soundings provided over model soundings for these particular cases?
I don't know if it's always something more that it's providing, but yeah, added value. I think it's just another comparison. I mean, when you're utilizing buff kit, you don't always look at just the wrap or the her, you compare all the different models. So I think it just adds another model into it, and it's on the observational side of things. So it's in comparison, especially when you have actual upper air observations. I do find these useful and added value to see how they compare with the observational side of things. So I just think it's another tool to look at, compare, see how the models are doing. You can start throwing things out and things like that.
All right. In addition, Sylvia mentions that there's a paper that shows an interesting application of NUCAPS SMPP stability products in case of deep convective development over the Texas-Oklahoma region. So you can check out that paper there. In addition to that, Pat S. asks, are there NUCAPS gridded fields archive available anywhere?
Yeah, so I actually worked with Jarrell and then a few others from sports. So Emily Burnt and Rebecca Esmali and Bill Line. So Dan Bykos. I've been working with a few people that it's not readily available, on the internet, I don't believe, but they can provide you with some of the data. I am working with Dale Morris, who works with the West 2 Bridge. And right now you can get the NUCAPS, gridded NUCAPS. If you were able to get the data sets, you can actually ingest those into your West 2 Bridge. However, there's not a capability of showing the gridded NUCAPS field. So you're only able to get the soundings. So I think that they're working on potentially adding that into the West 2 Bridge. So if you do archive cases in a local office, you could then load it into the West 2 Bridge with the gridded NUCAPS. Otherwise, yeah, I don't know if Jarrell, you want to add on to that. I don't think that they have the online version, but it only goes back a couple days, like gridded NUCAPS.
Yeah, like from my perspective, so I have a AWIPS archive, AWIPS NUCAPS archive here at CIRA, and it goes back the past few years. And of course, there's certain dates that I won't have due to like data outages and stuff like that. And usually I can also redisplay the gridded NUCAPS data sets, but right now our CIRA local AWIP system does not have that functionality at the moment. We're trying to get that fixed. I do have that capability for any other users that are interested in archived NUCAPS data sets. But I also wanted to highlight, and you can just look into the chat here, there's also from NASA Sport, there's some imagery, near real-time imagery from grid NUCAPS that users can access online as well. And you can just click on that link for any interested users. But I wanted to additionally mention, I think Tom Clemens also had a question here. He says, talking to the floor here, is there let's see here, is there a way that we can, or we could create a blended NUCAPS sounding with CAM model data to see if that will help the temp bias that NUCAPS has? Did you have any thoughts on that, Kaitlin?
Yeah, I mean, I'm not sure about if I can create it, but I definitely would be on board if that was something that could be done. Maybe it could be looked at in a hazardous weather test bed sense. That'd be something you could test along. I don't know if the SharpEye product is able to encompass that. But yeah, I definitely think, yeah, if we could pull in somewhat, maybe even just some of the observational surface temps and ingest those into the NUCAPS as a modified way, which I think they already have modified soundings, and that might be what they're already doing. So you might want to, I don't know if Tom, you have access to that SharpEye, it loads onto the AWIPS. So you might want to get in contact with them. And if you want to email me, I can try to help forward you along to the right people. But you might want to look into some of those modified soundings that they already have. And I think they're working on trying to get those into AWIPS, but I could be wrong. So.
All right. Well, sounds good. Well, I don't have any other questions, but I know Jordan has one last question before we come to a close. So Jordan, take it away.
Yeah, thanks, Jarrell. And Kaitlin, thanks for your presentation. Right off the bat on slide 7 with your first case, you showed that comparison of the precipitable water between NUCAPS and the SBC mesoanalysis. And I was really struck to the point I became distracted for the rest of your presentation by how different though. I mean, you had 2.4 inches in the or excuse me, 2.4, is that centimeters? Oh, I see. Okay.
Yeah, it was meters. Yeah.
Okay. Never mind. Okay. Thank you so much for clearing that up. And then my second question is with regards to the day cloud phase distinction RGBs. They become redder as you head towards sunset. Has there been any issue with interpretation of those?
No.
Because of the change in the sunlight?
I don't think so, because a lot of times if it starts to transition, towards that redder, a lot of times we'll try to switch over to the nighttime microphysics, which isn't as, to me, it isn't as detailed and great as the day cloud phase distinction RGB, or the sandwich product then starts to come in handy. So I think I think forecasters are quite aware of when that starts to happen, the sun starts to set, you start to lose that detail.
Okay, thank you so much. All right, Jarrell, if there's nothing else, I'll wrap it up here.
Sounds good.
Okay, so thank you so much, Kaitlin, for your presentation today. I really enjoyed it. Hope everybody that tuned in did as well. Lots of good insight. Always good to hear how you're using data on the ops floor. And thanks, Jarrell, for moderating. I'll just wrap up by reminding everybody again, this is something that happens every Thursday, usually at noon Eastern time. Next week, we got Bill Line from the NESDA STAR RAM-B. He's going to discuss satellite imagery applications during burn, scar, flash flood events. So something that's going to be very relevant, particularly out west. Until then, please feel free to contact our Tower S team if you have any questions about the Satellite Book Club or related to the configuration of satellite products. It's always good after these to check out what you have in AWIPS and make sure the configurations are up to date. And if not, our Tower S team can help you with that. So that's it for today. Stay well, and we'll see you next week. Bye, everybody.